Today we are going to look at integrating functions of the form f of ax plus b. That is, a function of a linear function ax plus b. For example, if I have sine of 3x plus 7, it's a trigonometric function of ax plus b, a linear expression. Another one, e raised to 2 minus 8x. The basic function is e raised to x, but instead of x, I have 2 minus 8x. Yet another example, 8x plus 9 to the power of minus 5. This is like x raised to n. It should have been x raised to negative 5, but instead of x, I have 8x plus 9, a function of the form ax plus b. Again, 1 by 3x plus 4. And this is like 1 by x, but instead of x, I have ax plus b, 1 by 3x plus 4. A function of ax plus b. We are going to look at this particular derivative of d by dx of ax plus b the whole raised to n plus 1 by a times n plus 1. The first thing what I notice is that the denominator a times n plus 1 is a coefficient, and so it stays the same. In the numerator, I apply chain rule. It looks like x raised to n, so it will be n times x raised to n minus 1. So here it is ax plus b to the power of n plus 1. So that's going to be n plus 1 times ax plus b the whole raised to n plus 1 minus 1, and then multiply by the inner derivative a. So what happens is a and a cancels, n plus 1 and n plus 1 cancels, so I have ax plus b the whole raised to n. So if I know that the derivative of this big expression given to me is ax plus b the whole raised to n, the other way around, integral of ax plus b the whole raised to n dx is ax plus b the whole raised to n plus 1 by n plus 1 into a 1 by a. And of course there is plus c. So what exactly did we do here? If your question looks like x raised to n, it's going to be x raised to n plus 1 by n plus 1. So for ax plus b the whole raised to n, we still do the same. X raised to n is x raised to n plus 1 by n plus 1. So ax plus b the whole raised to n is ax plus b the whole raised to n plus 1 by n plus 1. And then I have an into 1 by a in the front, which means I divide by the inner derivative, which is a. Looking at another example, d by dx of derivative of e raised to ax plus b by a. When I try to differentiate again, divided by a is a coefficient which stays there. Numerator is like e raised to x. Derivative of e raised to x is e raised to x itself. So derivative of e raised to x plus b, I apply chain rule, would be e raised to x plus b itself times by a. A and a cancel, so I have e raised to x plus b. So undoing it, integral of e raised to x plus b dx is the original question, which is e raised to x plus b divided by a plus c, or can be written as 1 by a times e raised to x plus b plus c. So how exactly did we do this? Integral of e raised to x is e raised to x itself. But if I have integral of e raised to x plus b, then it becomes e raised to x plus b itself, but then I divide by the inner derivative a. Ax plus b derivative is a. Or I keep it as 1 by a outside. Again, derivative of sine of ax plus b divided by a. Divided by a is a coefficient, so it stays outside as 1 by a. And derivative of sine of ax plus b is cos of ax plus b into a. This a and a would cancel, and I get cos of ax plus b. So undoing it, cos of ax plus b integral would be sine of ax plus b divided by a. So how did we do that again? Integral of cos x is sine x. Integral of cos of ax plus b would be sine of ax plus b. But I have a 1 by a, or rather I divide by the inner derivative. So putting these results together, the first one, integral of ax plus b the whole raised to n dx. I treat it like x raised to n. integral of x raised to n is x raised to n plus 1 by n plus 1. So ax plus b the whole raised to n is ax plus b the whole raised to n plus 1 by n plus 1, but I have a 1 by a, the inner derivative, plus c. I need to also mention here that n is not equal to minus 1. What if n is minus 1? Then it becomes ax plus b the whole raised to minus 1. Isn't that the same as integral of 1 by ax plus b dx? And what's integral of 1 by x? Integral of 1 by x is ln mod x. So integral of 1 by ax plus b would be ln mod ax plus b. But of course, I need to divide by the inner derivative. So into 1 by a plus c. Third result, integral of sine of ax plus b dx. Integral of sine x is minus cos x. So integral of sine of ax plus b would be minus cos of ax plus b, and then divide by the inner derivative a, or keep it as 1 by a in the front. Fourth result, integral of cos of ax plus b dx. How do I integrate cos x? Integral of cos x is sin x. So integral of cos of ax plus b would be sine of ax plus b divided by a, the inner derivative, keep a 1 by a, plus c. And finally, integral of e raised to x plus b dx. Integral of e raised to x is e raised to x itself. So integral of e raised to x plus b would be e raised to x plus b itself, but you have a 1 by a outside, plus c. So basically, we integrate these functions like normal and then divide by the inner derivative. We're going to look at an example. This is from exercise 18F, question number 1a, integral of 2x plus 5 the whole cube dx. Doesn't the question look like integral of x raised to n dx? And we know that it becomes x raised to n plus 1 by n plus 1 plus c. But this is not x raised to n. This is ax plus b the whole raised to n dx, which is ax plus b the whole raised to n plus 1 by n plus 1 into 1 by a plus c. So taking this question here, 2x plus 2x plus 5 the whole cube dx would be 2x plus 5 the whole raised to 4 by 4, and then I should divide by the inner derivative. Derivative of 2x plus 5 is 2. So I have into 1 by 2 in the front plus c, which simplifies to 2x plus 5 the whole raised to 4 by 8 plus c. Question C. Integral of 4 by 2x minus 1 the whole raised to 4 dx. It does not look like integral of x raised to n dx. So I need to first change this into that format. For that, I take 2x minus 1 into the numerator. And 4 is a coefficient. I could keep it outside the integral. So this is what we get. And we know that integral of ax plus b the whole raised to n dx would be ax plus b the whole raised to n plus 1 by n plus 1 into 1 by a plus c. So 4 coefficient stays here. Then 2x minus 1 to the power of minus 4 plus 1 divided by minus 4 plus 1. Then I divide by the inner derivative 2, so it becomes 4 by 2 there. So that's my 1 by a outside, which on simplification gives me minus 4 by 6 into 2x minus 1 to the power of minus 3 plus c. The negative power term can be brought to the denominator. So it gives me negative 4 by 6 times 2x minus 1 to the power of 3 plus c. Negative 4 by 6 further simplifies, and so that's my answer. Looking at this example, integral of root of 3x minus 4 dx. The question doesn't look like ax plus b to the power of n. So I change the square root form to 3x minus 4 to the power of 1/2 dx. Now it is like ax plus b the whole raised to n. X raised to n becomes x raised to n plus 1 by n plus 1. So I add 1 in the power, divide by the same thing, and also I keep a 1 by a in the front. So 3x minus 4 to the power of 3 by 2 when I add 1 in the power divided by 3 by 2, and I should not forget to keep 1 by a in the front. So into 1 by 3. On simplification, that's what we get. Look at this example. So I'm trying to put 3 different terms into one question. I have an exponential function of ax plus b, plus I have a trigonometric function of ax plus b, and a simple 5 times x cubed dx. So looking at the different results, integral of e raised to ax plus b is e raised to ax plus b itself, and then I have a 1 by a in the front. Sine of ax plus b integral is minus cos of ax plus b divided by a plus c. So trying to apply these results into this question, I integrated term by term. So that's my question, and I would integrate the 3 terms term by term. E raised to 3x minus 7 integral is e raised to 3x minus 7 itself divided by 3. So I am done with the first term. Looking at the second term, sin x integral is minus cos x. Sine of 2x plus 8 would be minus cos of 2x plus 8 divided by 2, the inner derivative, or keep a 1 by 2. And when I look at the next term, 5 is a coefficient which stays there, and x cubed is x raised to 4 by 4 plus c.